Hey everybody, this is Mr. Brooks. I was grading the linear inequalities and I wanted to share a video because I think there's some misconceptions. Um, so a lot of people got the y equals xb fine where they, start at the y-intercept and then follow the slope. And that would be like this person, for example. Okay, so, there's an intercept at -1, and -1, there's an intercept at 3, positive slope, negative slope. We find where the lines connect. So if these were equations with an equal sign, that would be all you have to do. So with an inequality, the answers are range, and we're going to have to do two things. We're going to have to show if the answer is inclusive or non-inclusive with either a dashed line or with oh gosh. I hope I can do this. Let's see. Oh, here I can do this. You have to show if it's a dashed line or a solid line. And so, for example, both these on number 13 are greater than or equal to, so these are solid lines, just like this. But look at 14. 14 is only greater than for both of them, okay? So we're not going to have a solid line. This would actually be where it's a dashed line, okay? And the reason it's dashed is because it doesn't include where the line is. All right, so that's the first thing. If it's or equal to, then it's a solid line. But if it's not or equal to, then it has to be a dashed line. All right, the same way when we graphed with just one variable, we showed an open circle or a closed circle, okay? And when you have two variables, you need to show a dashed line or a solid line. Now, the other thing is that we are going to have to show where it's shaded, okay? So if it's greater than, so both these are greater than, so I'm going to shade above both of these. And that would be like right here above, this side above. And then also like right here, right? So I'm going above both these lines. Now, the solution set is everywhere that's true for both inequalities. Okay, so basically where is it on the graph that both lines, or it's shaded twice? Both lines are shaded in the same area. Okay. And since they're both above in this, that means that it's going to be shaded right here. So this is the solution set. Okay. You need this. You need to show dashed, solid, and then where it's shaded. Okay, so over here, let's just look at 15 real quick. So 15, the line at +1 is dashed, and the line at +3 is solid. So the line on top of here, this should be solid, but this one should be negative. And I'm gonna have trouble with this. I know I'm gonna have trouble with this. Come on. So I'm going to shade this. Okay. And then I'm not going to shade the other one. So notice this one is or equal to, and this one is just, less than. So it looks like it's less than for both. So that means I'm underneath for both. And this one would be where there's no solution because, well, no, that's not true. It would be right there. So less than for this one and less than for this one, and they're both shaded right here. So only underneath the leftmost line, okay? All right, so is there one where, let's see, in this set, they're all either greater than or less than. So this one would be up here, and again, this would be dashed. And this one would be greater than and greater than, so this one would be up here, and this one would be dashed, okay? But when you do these, go back and make sure you're paying attention to, is it a solid line or is it a dashed line? And then pay attention to if it's shaded above or below. And the solution set is where they're both shaded. Okay.